lessons, we've learned linear number sequence and non-linear number sequence. Then you remember what is linear number sequence. So the number that are increase or decrease by the same number. Non-linear sequence, the numbers are increase or decrease by different amounts, right? Then to find the formula for the linear sequence, add first number, add n minus 1 times common difference. And we also talked about the special number sequence as well. So in terms of the linear number sequence, we knew that two special number sequence, that is even number sequence, formula is 2n, and odd number sequence, formula is 2n minus 1. In terms of the non-linear number sequence, we talked about lots of special number sequence, that was square number sequence, n squared, cube number sequence, n cubed, and sum of odd number sequence is the same as a square number sequence, that is n squared as well. Then finally, we talked about the triangular number n times n plus 1 divided by 2, right? So now in this video, we will practice more non-linear sequences, but please remember, identify whether the number sequence is linear or non-linear. Then now if it's non-linear, try to recognize the special number patterns. Then if it's not, then we need to figure out our formula by ourselves. So let's practice together. So this number sequence has got a picture. So whenever you've got a picture, just try to write down the number, right? So first pattern, second, third patterns. So let's see how many triangles, because it says number of triangles are the pattern for the number. So we can see one triangle, second pattern, top, and then 3. So 1 plus 3 is 4 triangles altogether. Then I think we need to focus on the bottom rows, and then this one is very familiar. I think we did it, right? Set 9, and then now you add up all triangles to the bottom one is 7, then you add up together is 16. Then can you think about the fifth pattern, because it's keep adding. So your bottom row is 1, 3, 5, 7. Keep adding all the number rise, add up 9, it gives you 25. So 1, 4, 9, 16. I said you need to focus on each numbers. This is the square number. So now let's see, special name for this sequence is a square number pattern. And you also can say this is a sum of odd number pattern as well, because they are the same pattern, right? Then sum of odd numbers. So now let's see, we need to find how many triangles are needed to create the 15th pattern. That means your n is 15. So your nth term formula is a square number pattern is n squared. So now all you need to do is n equals 15. So 15 squared, 15 times 15 is 225. If you remember sum of square numbers, then your calculation will be super fast, okay? So try to remember 15 squared is 225. So let's move on to the next question. Again, we've got a pictures instead of the number, but still same. Let's figure that out. So pattern 1, how many circles? 1 circle. The next one, we can see 1, 2. Ooh, so 3 circles all together. And then 1, 2, 3. Keep adding the numbers. It's very familiar. I think we did it, right? Can you remember this pattern? Then what about pattern 5? Look, we're adding up 1, 2, 3. The next number will be 5, right? So look, the pattern will be you adding 1, then 2, 3, 4, 5. This is the, yes, right, look at the figure. That is the, look at the shape. This is a triangular number. Triangular number is you're adding all the consecutive numbers from 1, right? Then how many circles are needed to make 19th pattern. That means your n is 19. That means you add up numbers from 1 to 19, right? What is the sum of the numbers from 1 to 19? You remember the triangular number. And think about the parallelogram. N times n plus 1, then divide by 2 because it's a triangle, right? Then now let's put the numbers, the number 19 inside the formula. 19 times 1 more than 19 is 20, right? Divide by 2, so 19 times 20, divide by 2, so simplify 2. Then 190 is the 19th term. So we can say 190 circles are there all together. Next one, let's see. Look at this pattern. So definitely you need to identify whether these are linear sequence or non-linear sequence. Let's find the common difference, okay? Because these number sequence looks really tricky. Let's see. Look, 1, 2, the difference between the term is nonsense, -1 plus 6. I really don't get it. You can't see any patterns, right? So in that case, what you need to do is try to focus on the numbers that I circled as red, okay? 1, 4, 9, just jump, skipped, then 16. So focus on all the red numbers. Can you recognize these numbers? Yeah, now you must say to me, these are the square numbers, right? So now this is 2 squared, 3 squared, 4 squared, and your next number is 5 squared. Well done. So your number is 25. So remember, when you see really tricky number sequences, just think about 2 number sequences joined together create a new number sequence, okay? Just think about that. Now let's move on to the next one. Let's see the difference between the term 0, 2, -1. Oh, no pattern as well. So now let's see. Maybe this is the joined pattern as well. Let me circle 1 and 3, skip, and 6, skip, and 10, 15. Then I think I can see some patterns. Let's find out the difference between 1 and 3. That is a 2. 3 and 6, that is a 3. Oh, I see. That is a special number sequence. Can you remember? What is the number sequence? What is the name of this number sequence? Triangular number, right? You kept adding 1, 2, 3, 4 each time, right? So that's why I focused on the too much about special number sequence. So now, next one. This is the same. Look, you got a joint sequences. Then you need to find 2 numbers, right? So again, let me just double check. There's no pattern, right? Then now I'm going to find out the 2 patterns. So using different pen. Let's focus on the old number orders. So 1, 3, 6, 10, 15. Then your first missing number is the blue pattern. Oh, it's the same. Look, 1, 3, 6, 10, 15 is triangular number, right? You adding up the numbers. So 21. Then I said you need to be familiar with the triangular numbers. And this one is, oh, we need to think about it. 1, 2, 2, 4, 4, 8, 16. This is not the special number sequence. We need to figure it out by ourselves. So let's see the pattern. What's happening here? Oh, double. Look, previous number is doubled. 1, double 1 is 2, double 2 is 4, double 4 is 8, double 8 is 16, and double 16 is 32, right? So now let's try our challenge questions. So pause the video, then read the question and try to solve it by yourself. So always word problem, thinking about your final goal. And then final goal is a difference between Liam's fifth number and Rui's fifth number. That means you need to find the two number sequences, right? The formula for the two number sequences, Liam's sequence and Louis. So now let's see. Liam's sequence is 2, 5, 8, 11, and Louis is 3, 5, 7, 9. So what did you notice? So let's find our nth term formula. Then identify whether these sequences are linear or non-linear. So let's see the difference. Oh, the Liam's one is it increased by 3, right? Can you see the common difference? That is a 3. So whenever you got a linear number sequence, add first number, then n-1 times common difference. Then it already says on the questions the numbers and count of 3s. That means this is a linear sequence. So now times 3. 2 plus 3n, expanding bracket, 3n minus 3, and then let's simplify the 3n minus 1. Now we come up with our Liam's formula, 3n minus 1. Let's focus on Louis. So Louis as well, starting by 3 and count it up to, that means your first number is 3 and your common difference is 2. This question is really kind, yeah? They gave you everything to you. So let's write it down. And also you can see these are odd number pattern, but we can't use our odd number formula because it begins with a 3, not 1. So let's just use the linear number sequence of formula that is adding first 1 and then minus 2 times 2. Then let's simplify. That is a 3 plus 12 minus 2 and 2n plus 1. If it was beginning with a 1, definitely 2n minus 1 is the formula. But as you can see, first number is important for your linear number sequences. That's why it's 2n plus 1. We are looking for our final goal is a fifth number for Liam and fifth number for Louis. That means your n is 50. So 3 times 50 minus 1. That gives you 149 is Liam's fifth number, and Louis' fifth number is 2 times 50 plus 1, and that is 101. This is now what we need to do is find the difference between the fifth number. So 149 take 101, and the difference is it's not 38, it's 48. This is my mistake. So the answer is 48. Let's have a look at this one. Then now pause the video and then try to figure out by yourself. But remember, this pattern is not only one pattern, okay? So let's have a go. So how was it? Let's do it together. Below is a sequence of square and dots. I said it's 2 patterns, right? Then now we need to focus on the square pattern and then dot pattern as well. So now how many dots will surround the diagram with a row of 20 squares? Now before we starting the question, let's write down first, second, third pattern. Then we come up with the nth pattern. Finding the formula is the first job, right? Then, as I said, this is the joined pattern. So let's focus on our square pattern. 1, 2, 3. Then your n will be, first number is 1, second number is 2, third number is 3. That means nth number will be n. So it's simple, right? Your square pattern will be n. Then let's see our dots. So first you've got 4 dots, 6. Then let's count up 8. Then your nth number, nth pattern will be, let's see. Oh, the dots increase by 2. So this is a linear number sequence. Then linear number sequence 4 plus first number plus n minus 1 times the common difference. And then that gives you 4 plus 2n minus 2 is 2n plus 2 is the formula for the dot sequence. So now I'm going to write down 2n plus 2. Then let's have a look at the question again. How many dots will surround the diagram with a row of 20 square? So 20 square means what? We need to focus on our dots formula, but 20 square gives you information. That means your n is 20, right? 2 times 20 plus 2. You just put 20 inside the square pattern, square formula. That gives you 42. Now, your second question is, how many squares are in the diagram which has a 148 dots? My spelling mistake, sorry about that. Now, how many squares? So now, thinking about our square pattern, then square pattern formula is n. Then if you can see 148 dots, that means the dot pattern formula is 2n plus 2. That means 2n plus 2, when 2n plus 2 is 148. How many square can you see, right? Then you need to find your n. That's the question, right? So now this is all algebra. Let's find the n. So you move the terms. 2n makes, take away 2 is 146. So 2n gives you 146. So let's find our n. So n is 73. That means when you have a 73 squares, the dot will be 148. So well done. So we will practice more challenging number sequence problems next session. So see you at next lesson. Bye.